Hello everyone, I'm Jaeyoung Kang from the Visual Intelligence Lab at KAIST. Today I'll present our work, Event6D, the first event-based framework for novel object 6D pose tracking. This is joint work with my collaborators at KAIST and NVIDIA. Let me first define our task. 6D pose tracking estimates how an object's pose changes from the previous frame to the current one, given a CAD model and live sensor input. The key constraint here is novel objects. The test objects are never seen during training. This is a strict generalization setting that matches real-world deployment. Existing trackers like Foundation Pose use RGB and depth cameras which run at only about 30 frames per second. Under fast motion, this causes severe motion blur and the tracker fails, as shown on the left. Event cameras solve this. They capture brightness changes asynchronously with microsecond latency. By using events during the blind interval between depth frames, we can track at sub-frame rates, much denser than the original 30 Hz. Most 6D pose trackers, including Foundation Pose, follow a render and compare paradigm. They take the previous pose, render the CAD model at that pose, and compare the rendered image to the sensor input to refine the pose. Bringing events into this pipeline raises two key challenges. First, a modality gap. The rendered CAD image is RGB depths, but the sensor stream is sparse events. You cannot directly compare them. Second, missing depths. Between two depth frames, depth simply doesn't exist, but reliable 6D tracking depends on depths. So we need a way to estimate depths during the blind interval. Our method can address both problems. Our solution is image depth dual reconstruction from events. On the left, an events-to-image network reconstructs an intensity image from the event stream. This bridges the modality gap so we can compare against the rendered CAD view. On the right, a depth extrapolation network takes the last known depths and the intervening events to predict depths at the current time step, filling the blind interval. Together, at any time, we now have both an intensity image and a depth image derived purely from the initial depths and events. This is the core enabler for dense tracking. Here's how it plugs into tracking. At tau equals 0, we have real depths. For every subframe moment up to tau equals t, we use the dual modal reconstruction module to produce a synthetic intensity and depth pair. We then feed these pair into the pose head to estimate the current pose. The process repeats recurrently, giving us pose estimates at event rate. To train this, we built the first large-scale synthetic event dataset for 6D pose tracking. Over 1,000 objects in dynamic scenes, which is essential for tracking. Each sample provides an RGB frame, the corresponding event frame, and depth ground truths, exactly the supervision our dual model reconstruction module needs. For evaluation, we go from synthetic to real. Since no real-world event dataset exists for 6D pose tracking, we built ourselves, using OptiTrack for pose ground truths, an event camera, and RealSense for depths. We captured 14 novel objects at 120 FPS. Crucially, the test objects don't overlap with training, so what you will see next is a true sim-to-real novel object evaluation. Here are the results on the real-world test set evaluated at 120 Hz pose query rate. Event Track 6D achieved the best accuracy across all metrics while running in real time. In particular, it remains robust under the fast and dynamic motion where existing trackers tend to fail. A qualitative comparison under rapid motion, Foundation Pose drifts due to RGB motion blur, while Event Track 6D continues to track the object accurately. Event Track 6D is the first event-based framework for novel object 6D pose tracking achieving state-of-the-art accuracy in real time. Thank you for watching.